everyone, and welcome back for another deep dive. We get tons of papers sent our way, but this one really got us thinking.
It's a fascinating paper, really.
Yeah, it's all about LLMs. Those large language models,
All right.
the ones that everyone's talking about. But this paper tackles this big question: Can we ever really stop LLMs from hallucinating?
Hallucination, yeah.
I mean, can we prevent them from just making stuff up, giving us wrong information?
It's interesting because this paper, it doesn't just say, oh, let's train them better, let's just throw more data at it.
Yeah.
It actually goes deeper. It asks, are there fundamental limits here?
Right. It's not just about making them better. It's about, are there some things that they inherently can't do?
Yeah. Are there things they just cannot do?
And I love how they set up this idea of a, formal world.
Right.
Have you ever heard of this?
Yeah.
So, it's like they create this simplified universe in the paper where everything has a definite right and wrong answer. Like, we know for sure what the ground truth is.
Right. There's like this, what they call the ground truth function in this word.
Ground truth function,
yeah.
Exactly. And it's from that they then define what hallucination is.
Right. So it's any time that an LLM gives an answer that doesn't match this ground truth function, they say that's a hallucination.
Yeah.
And they break it down even further. They talk about total hallucination where the LLM is always wrong.
Always wrong. Okay.
Some hallucination where it gets things right sometimes.
Okay.
And then the holy grail hallucination free.
Yeah.
Where it just never hallucinates.
The perfect LLM.
A perfect LLM.
Well, I hate to break it to you, but this paper says that might not be possible.
It might not be possible.
They actually make this bold claim. Hallucination, they say, is inevitable. Not just likely, but mathematically, it has to happen with any LLM, no matter how advanced we make it.
Yeah.
Whoa, hold on. How did they figure that out?
So they use this technique called the diagonalization argument.
Diagonalization.
It's a little bit mind-bending.
Yeah, diagonalization, it sounds complicated.
But it's basically, imagine you're trying to list out every possible answer an LLM could give.
Right,
okay.
I'm trying.
Yep. What the argument shows is that no matter how you do that, there will always be some correct answers that are missing from that list.
Some correct answers are missing, so it's incomplete no matter what.
You just can't capture everything. It's like trying to fit an ocean into a swimming pool.
Wow. So does that mean that we're doomed to these weird, hallucinations forever?
It's not about a specific LLM being flawed.
Okay.
Right. It's saying that there's this fundamental limitation.
Oh, I see.
Think about it this way.
Yeah.
Even the fastest car has a top speed.
Okay.
Right.
Yeah.
There's physical limits to what's possible.
Yeah.
And they're saying that there are similar computational limits to what LLMs can actually do.
So it's not about just training them better or adding more data. It's about there are just some things they fundamentally can't do.
Exactly.
That's crazy.
Yeah.
So this whole inevitability thing, it really comes down to what LLMs can actually compute. There are just some problems that are too much for them to handle perfectly.
Exactly. And they give this this cool example in the paper to illustrate this. Imagine you ask an LLM to list all possible strings of a certain length using a fixed set of characters.
Okay, all possible strings of a certain length. Okay.
It sounds simple, but it's deceptively difficult because the number of possibilities, the number of strings explodes as that length increases. And they say that even the biggest LLMs we have today, they fail surprisingly quickly on this.
Oh, really? What's
that? They give this concrete example, listing all the strings of length 7 using only the letters A and B.
So just A and B, 7 letters long? That doesn't seem that hard.
It seems simple, but there are actually 128 possible combinations.
128. Wow.
Which is already a long list to write out. It's like 896 characters long.
Wow. It's more than I thought it would be?
Yeah.
Okay, so it explodes quickly.
It explodes quickly.
Yeah.
And the point they make is that even these huge LLMs, even with these enormous context windows, they can't handle this task.
So it's like asking a calculator to do advanced calculus. It's just not built for that.
Yeah, exactly. You need a different tool for that.
So even these seemingly basic tasks, they can become computationally overwhelming really fast.
Yeah, they hit a wall. Not because they're dumb, but because the problem just requires so much computational power.
Oh, wow. Okay, so they hit a wall.
Yeah.
So what do we do? I mean, are we just stuck with these hallucinations? Like, is there any hope here?
Well, the paper does explore some strategies for mitigating these hallucinations.
Mhm.
It's all about understanding the trade-offs and using LLMs, strategically.
So there is hope. Well, that's what we're going to explore in part 2. So, okay, we've kind of established this unfortunate truth that LLMs are going to hallucinate, at least sometimes.
It seems to be baked in.
It's baked in, but we're not totally powerless, right?
Right.
I mean, the paper you sent, it talked about some pretty clever ways to at least try to reduce these hallucinations.
Yeah, there are definitely things we can do.
I'm really curious to hear more about those. What are some of those strategies?
Well, one that might seem obvious at first is just, building bigger models, feeding them more data.
Yeah, like the merrier kind of approach.
Exactly, like if you want to see fainter stars, you build a bigger telescope.
Right.
So the thinking is, if we make these LLMs more powerful, maybe they'll be able to handle those really complex problems without hallucinating as much.
That makes sense. But I remember the paper saying there are some limits to that approach. Like, it's not a cure-all.
Yeah, you're absolutely right. It comes back to that core issue of what actually computationally possible.
Yeah.
Like if a problem just requires a level of computation that the LLM can't reach, then no amount of data or layers is going to magically solve that.
Okay, so it might help up to a point, but there's a ceiling.
Yeah, there's a ceiling, exactly.
Like, it's kind of like adding more lanes to a highway.
Oh, okay.
It'll help with traffic flow, but if everybody's still trying to squeeze through the same tiny toll booth at rush hour,
Right.
you're still going to have a bottleneck.
You're still going to have a bottleneck. That's a great analogy.
So it's not always about just brute force.
Exactly. It's about working smarter, not harder.
Okay, working smarter. So if just going bigger isn't always the answer, what about giving our LLMs like a little bit more guidance?
That's a really interesting idea, and that's where prompt engineering comes in, right?
Prompt engineering. Yeah.
Giving the LLM more context, clearer instructions, maybe even some examples of how to reason through the problem.
Yeah. This is something that I bet a lot of our listeners are already, playing around with.
Absolutely. And it can be incredibly powerful because by providing more context, you're essentially giving the LLM more clues about the ground truth of the problem.
So you're helping it navigate that huge space of possible answers.
Exactly. You're narrowing down the possibilities.
Okay, that makes sense.
And there's, within prompt engineering, there's this idea of chain of thought prompting.
Chain of thought prompting, yeah. Yeah, I was really curious about that. Can you explain how that works?
Yeah, so it's basically like you walk the LLM through the reasoning steps.
Oh, okay.
Almost like you're showing it how to think.
So you're giving it a little like a roadmap.
Exactly, like a roadmap. And it can be super effective.
Yeah.
But it's important to remember that it's not, a magic bullet. It works best when the problem itself is fairly straightforward and you can break it down into like clear steps.
Okay, so it has its limitations.
Yeah, it has its limitations. For really complex or nuanced tasks, it might not be enough.
Gotcha. So it's another tool in the toolkit, but we still need to choose the right tool for the job.
Exactly. And the paper also touched on a few other techniques just to give a sense of, how much research is happening in this area.
Oh, yeah.
For example, some people are experimenting with using ensembles of LLMs.
Ensembles, like a musical group.
Well, kind of. It's like you combine the output from several different LLMs, to get a more accurate result.
Oh, so it's like getting a second opinion from a doctor.
Exactly. More perspectives can lead to better decisions.
Makes sense.
And then there's this idea of building guardrails into the systems, like, rules that try to prevent the LLM from going off the rails, so to speak.
Okay, yeah, keep it on track.
Keep it on track. And then there's a lot of work on, incorporating external knowledge sources like databases or knowledge graphs. So you give the LLM a much wider pool of information to draw from.
Give it access to, like, a whole library instead of just one textbook.
Yeah, exactly. So, even though we have these limitations, there's clearly a lot of really exciting work being done to try to make these LLMs more reliable.
That's really encouraging to hear. But I gotta say, knowing that this hallucination thing is kind of a built-in feature, it makes me think, how should we, as users, how should we be thinking about using these tools?
Right.
It feels like we almost need, like, a whole new kind of literacy,
Yeah.
A way to understand both the amazing power and the potential pitfalls.
I think you've hit the nail on the head.
Yeah.
It's all about becoming informed and discerning users.
Informed and discerning. Okay.
We need to be able to critically evaluate what the LLM is telling us.
Yeah.
Understand when we can trust its output and when we need to be a little more cautious. And we also need to remember that these models are products of human design, you know,
Right.
which means they can reflect our own biases and limitations.
That's a really important point.
Yeah.
So where do we go from here? What are the big takeaways from all this?
Well, I think, first of all, it's crucial to remember that these LLMs, they're incredibly powerful tools.
Yeah.
They're already changing the way we work, learn, and create.
Yeah. Yeah.
But they're not magic.
Right.
And they're not a replacement for human intelligence. We need to approach them with, a healthy dose of skepticism. And always keep in mind those inherent limitations.
So be enthusiastic, but be cautious.
Yeah.
They're amazing assistants, but maybe not quite the all-knowing oracles we sometimes imagine them to be.
Well said.
Uh.
And that leads us perfectly into the final part of our deep dive.
Oh, the final part.
We've talked about the problems and some potential solutions. But what does all this mean for the future of LLMs? What are the broader implications? Stay tuned, because we're about to explore those very questions.
Okay, deep divers, we're back. And, we've been on this journey, this deep dive into LLMs. We've seen the good, the bad, the potential. But now it's time to really think big picture. Where do we go from here? What does all of this mean for the future?
It's a big question.
Yeah.
I think this paper really drives home the point that LLMs, for all their power, are still machines. They operate within the limits of what we can compute, and those limits, well, they're very real.
Yeah. It's like realizing, even the most advanced spaceship, it can't travel faster than the speed of light. There are just like fundamental laws of the universe we have to deal with.
Exactly. There are these boundaries we can't cross. And it makes you realize that, we can get so caught up in the hype thinking LLMs are like on the verge of being all-knowing. But this research, it kind of reminds us they're not. We've got a long way to go.
A long way to go. And it really highlights the importance of, of us, of human intelligence.
Yeah.
Like LLMs can help us, they can augment our abilities, but they can't really replicate the full spectrum of human thought.
Yeah. Especially when it comes to things like common sense reasoning, ethical judgment, emotional intelligence. These are areas where humans still have a clear advantage.
So knowing all of this, how should we be thinking about LLMs going forward? How should we be using them? It feels like we need like a whole new way of thinking about this.
All new literacy.
Yeah. A literacy that allows us to understand the power, but also the pitfalls.
I think you're spot on. We need to become really informed users. We have to be able to look at what the LLM is telling us with a critical eye to know, okay, when can I trust this output? And when do I need to be a little bit more cautious?
Yeah, be a little more skeptical.
A little more skeptical. And remember that, these models, they're designed by humans, trained on data, created by humans. So they can reflect our own biases, our own limitations.
So it's a bit like working with a brilliant but maybe sometimes unreliable colleague. You gotta appreciate their strengths.
Right.
But also be aware of their weaknesses and maybe double check their work when it really, really matters.
Exactly. And this paper, it really underscores the need for safeguards, what they call guardrails and fences.
Guardrails and fences, okay.
Yeah. We need to be thinking really carefully about how we design and deploy these systems so they don't cause harm. And so we're using them responsibly for tasks where accuracy is super important.
That makes a lot of sense. It's exciting to think about all the possibilities, but we also need to, proceed with caution. LLMs can be powerful allies, but we have to make sure that, that we're the ones steering the ship.
Yeah, we're the captains. And, it's not all about, preventing negative outcomes. There's a lot of potential for LLMs to actually enhance human creativity.
Oh, that's interesting.
The paper even mentions that sometimes, those hallucinations, those unexpected outputs, can actually lead to really fascinating and inspiring results, especially in fields like art and design.
It's like not all errors are bad errors.
Exactly.
Sometimes those unexpected detours, those lead to the most amazing discoveries.
Exactly. And LLMs, they could be incredible partners in the creative process, helping us to push the boundaries of what's possible.
I love that. Partners in the creative process. So, as we wrap up this deep dive, what would you say are some of the big takeaways here?
It's been a fascinating exploration, that's for sure. We've talked about these limits of computation, the importance of human oversight, the potential for challenges and opportunities as these LLMs, become more integrated into our
Yeah,
lives.
yeah, they're already everywhere.
They are, and it feels like we're just, scratching the surface. There's so much more to learn and to explore.
So much more to learn, and it's changing so fast.
Exactly.
Yeah.
And that's what makes it so exciting. We're learning more about the nature of intelligence, both human and artificial, with every new discovery.
Well, that's a perfect place to leave it. But dear listener, before you go, we want to leave you with a question. Knowing what you now know about LLMs, their limitations, how does it change the way you think about using these tools? What are your limits for trusting their output? We'd love to hear your thoughts, so share them with us. Until next time, happy deep diving.